Let's now see how the composite pattern is executed at the runtime using the debugging tool in Visual Studio. Okay, let's now go to the tests that we just developed from the previous tutorial video. If you go to test structure over here, and then we would like to see how this test case over here is executed at runtime and how the individual objects has been connected to each other. Okay, so now to see the debugger, let's now go to flat view over here. And then the flat view simply accumulates all the code from the ancestor class that of the test structure class over here. Okay, let's just type the feature name test expression structure. Okay, I'll type the name over here. And now let's just put that in line number 1. Okay, just this line here. Okay, now let's say run over here. And now you will see that now the system execution pause over here. And now you will see that at the moment we have local variables. You can see, so these are the local variables we expect to see. You got A1, A2, addition 1, addition 2, C1, C2, C3, and also E1. Okay, so let's see how they are created and connected to each other. Okay, first of all, after this line over here, we are going to actually see, first of all, you can see that E1, let's see some polymorphism and dynamic binding. Okay, this one will be good to illustrate. You can see E1 was declared as of static type expression. Okay, now the thing is, when we say E1.make, so which version of make is it going to take? It's going to call. According to dynamic binding, it is called the version of make of constant. If we say step into, let's predict what's going to happen. If we say step into, it's going to step into the make feature of the constant class because that's the dynamic type. If you say step into, you will see that now we are in the make feature of constant. Okay, and then you will simply just execute one step at a time, and you will see that value is now set to 2. Okay, now if you execute one more line, now we are back to the context of the test. Now you can see that we do have one object over here, E1, and the E1 is of this address over here. Okay, so we're gonna just this absolute address, you don't have to worry about its value, but it'll be very useful to really see how the aliasing is actually happening over here. Okay, I'll just put E1 over here. Okay, you can put any expression value. From the previous one, I can just remove. Okay, I can just remove the C1 the value from previously. Okay, E1. Okay, now we do something similar, C2 and C3. Okay, if we do that, C2 and C3. Okay, and also I'll put C2 over here. I'll also put C3 over here. Okay, now, so they are all constant. So the type over here you see are the dynamic types of these objects. And then we also do the typecast. Okay, now you can, so this is not so difficult, but what I really want to show you is this. When we say A2.make and the E1 and C2, so here we're saying that A2.left should be set to E1 and A2.right should be set to C2. So what we will have is something like this. When you say A2, actually we gotta do some, so yeah, A2.left, okay? At the moment, we don't have anything yet, that's why it's error, okay? And then also A2.right, okay? At the moment, it's also void, okay? Which means it has not been set yet, okay? So now, when we create A2, and then we're gonna call, no, again, which make are we going to call? Are we gonna call the make feature in constant or in addition? In this case, it should be addition because the dynamic type of A2 is gonna be just addition, okay? So now, also, I want you to pay attention to the address for E1 and C2. So this is the address for E1, and this is the address for C2. They will be copied as the left and right of A2. Okay, if you step into it, you will see that now we are in the context of addition and the make. Okay, you will see that when we say children and make an empty list, you can see now children is now empty. And then over here, you will see that extend left, extend right. So now after this, you will see that under children, this is linked list. You will see linked list is unlike array, it's going to be a linked structure. You will see the first element here is something over here. We're going to double check that this is the same address as the E1. And also to the right, the next element in the list is the second element, which is this element here, and we'll double check that this is really the address for C2. Okay, we'll double check when we switch the context back to the test. Okay, now we are back here. So now this is after the make. Okay, now I want you to see that E1, the address here is exactly equal to the address for A2.left. You can double check by using some assertion, some expression. E1 reference equal to A2.left. You will see that it's true. Okay, similarly, you will see that C2, the address is exactly equal to A2.right, because we actually just set this E1 to be left and C2 to be right of A2. Okay, now you can see, say C2 is also equal to A2.right. That's also true. Okay, now you kind of get the idea. Let's just go a little bit further. I want to show you just a little bit more. Okay, let's go a little bit further. And now you can see that over here, we are trying to set A1.make and then A2 C3. Okay, the only thing I want to show you is, you can see that over here, we also got something called okay, let me just double check to make sure I do the right thing. So what we want to do over here is A1.make. Okay, so let's see what A2 is. So this is the address for A2, right? So this is the address for the first addition of the second level addition we just created. Okay, now we're going to create a first level addition. And the left of the first level addition is the second level addition, A2. Okay, let's just go over this. And now you will see that over here. Okay, let's just go a little bit further. So now you will see A1.left. You can see the address is exactly equal to A2, right? Because we have just set the A2 to be the left of A1. So A1.left equals over here A2 over here. Okay, you will see that the assertion here is simply just true. Okay, again, as I said, the absolute values for these objects are not really important. However, you should really see their relative relationship. For example, you can see the address of A2 is exactly the same as A1.left, simply because of this make feature here. Okay, so when you later on, when you try to debug for your projects or for your assignments, so this kind of technique is really important to realize when we have aggregation or aliasing, this is how things work in the debugger. Okay, stay watching.